Alright guys, today we are on page 3 of our notes. I know it kind of jumps around a little bit. We're on page 3 and we're talking about the segment addition postulate. So what that means, if I have a segment and it's broken up into multiple different pieces, I can make like an equation in order to solve for different parts. If B is between A and C, so notice how B is in between A and C, making A and C my endpoints. Then if I look at just AB, well, that's not going to work. And I add it to BC, that will get me my whole thing from start to finish, AC. So this is kind of like part plus part equals whole. Some people like to say small plus small equals big. So if we apply that to something, I'm going to take one of my parts, NM, add it to another one of my parts, MO, and that will give me everything, which is N to O. So what I did is I just took what is in NM, MO, and NO and plugged it in, so I didn't want to waste your time. But now we're looking at solving equations, and this might have been a while for you guys. So some of your teachers might have built a wall. I will not do that from this point forward, really, but you can build a wall to separate it. On each side, you need to do something called combine like terms. So get anything that looks like together. On the left-hand side, I have two numbers, 17 minus 5. 17 minus 5 is 12, and I did not touch my 3x, so it's plus 3x. And on the other side, there's nothing that looks alike, so I just keep it the same. Once you've combined like terms, then you can work on getting your x's together and your numbers together. Now, to cross the line, you must do inverse operations, which means the opposite. If you're on the same side of the line, you don't have to do that, but if you're crossing, you must do that. So let's do our letters first. I want to get my x's together. So if I need to move this 3x over, well, it's addition, so to move it, I need to subtract it. And I'm combining it with my other x. I'm going to be left with, well, 12, because there's nothing there. 3x minus 3x is gone. 5x minus 3x, you just do math with what's in front. So 5 minus 3 is 2. Keep your x and bring your 2 down. Now I need to move my numbers. So it's plus 2, I must minus it. 12 minus 2 is 10. 2x minus nothing is 2x. And 2 minus 2 is gone. Last thing, x is still not alone. There's a 2 there. Well, how is 2 attached to x? Well, it is attached by a tiny dot, which means multiplication. So to get rid of it, we must divide. Divide by 2. 10 divided by 2 is 5. Now, is that what they asked for? Nope. If we go up, they asked us to find NO. So to find NO, you need to plug x into NO. So I'm plugging 5 in for x. Well, 5 times 5 is 25. 25 plus 2 is 27. Go ahead and pause the video and try the check it out example on your own. All right, hopefully you have come up with something, because you will be using that to type into your answer at the end of this video. We're going to try a different type though, using midpoints. Now remember, a midpoint is in the middle. So it does what? It cuts in half. D is the midpoint. So remember I told you we put something called tick marks to tell us it's equal. D is the midpoint of EF. So ED is 4x plus 6. DF is 7x minus 9. That's already all put in there. Do I have the length of the whole segment? Do I have an expression that says what EF is? Well, if I look, I don't. So can I use what they just told me about in the fact that can I use part plus part equals whole? No, because you don't have the whole. But what we do have is we have that it's in the middle and that those two things are equal. So we have another equation called part equals part, and that only works if they tell you it's in the middle and therefore it's equal. So one of my parts is ED, the other part is DF. So I'm going to take those two parts and I'm going to set them equal to each other. Again, build your wall. Are there any like terms on either side? No, I don't see any. So let's get our x's together. To do that, I'm going to minus 4x. If there's no sign there, that means it's positive. So I'm minusing it to get it to the other side. 4x minus 4x is gone. I have 6. 7 minus 4 is 3. And I have my 9. Well, now I need to get my numbers together, so I'm going to add 9 to both sides. 6 plus 9 is 15. 3x. And my 9's cancel. Again, the only thing attaching that to it is a multiplication dot. So I must divide by 3. And x equals 5 again. Now, is that what they asked for? Nope, they asked us to find every single part of it. Well, if I'm finding ED, I'm plugging 5 in for x. 4 plus 5 is 20. 20 plus 6 is 26. Now, if ED is equal to DF, we don't need to do the math to find it. They're equal. So DF has to be equal to 26. And if ED and DF make up the whole segment, to find the final segment, so to find EF, you would just add those two together. So EF is 52. All right, we have some midpoints again, but this says I'm going to use midpoints and the segment addition postulate. So that's like, are we going to do part equals part? Or are we going to do part plus part equals whole? So we have to kind of figure that out and investigate what it's going to be. Well, I see that AB is 8x. And I see that B is in the middle. So if B is in the middle, that means I can put my tick marks. And if B is in the middle, that means that AB equals BC. All right, so let's keep reading. AB is 8x. AC is 2x plus 42. I'm missing something right here, BC. I don't have anything there. But what do I know about BC? Well, I know that BC is equal to AB. So what that means is I can plug in what that is. So I can plug in what AB is, which is 8x. Now guys, you can't do part equals part, because part equals part is going to be 8x equals 8x. Well, thank you. Yes, that's the same as 5 equals 5. So we can't use part equals part, because part equals part is going to cancel out. If you are given the whole segment, you must use the whole segment. There is no question about it. So we are given an expression for the whole segment, we must use it. So we will be using part plus part equals whole. My parts are AB and BC equals AC. AB is 8x, BC is 8x, and the whole thing is 2x plus 42. Build your wall. Combine like terms. Does anything look alike on either side? Yeah, on my left side, I have two x's. 8 plus 8 is 16x. Get my x's together. So I'm going to subtract 2x. There's no sign there, so it's positive. 16 minus 2 is 14. 2 minus 2 is gone. The only thing that attaches there is a multiplication dot. That multiplication dot tells you to divide. 42 divided by 14 is equal to 3. That's not what they asked for, though. So I go up here, and they asked for every single part. So AB is equal to 8x. And if AB is equal to 8 times 3, which is 24, remember we said it's equal to BC. So BC is also equal to 24. AC is just the two of those added together. So you could just do 24 plus 24 and get 48. But if you'd rather use the expression that they give you, go ahead and do that. It's just a little bit more plugging and chugging. But you can do 2 times 3 plus 42. Well, that's 6 plus 42, which is 48. So you can do it either order there. Now, guys, I need you to turn to page 6 and go ahead and complete this one on your own. Pause the video, and at the end of it, it will ask you for your answer for this one, so make sure you have something to type in for there. Make sure you bring any questions to your Zoom meeting tomorrow morning.